So I wanted to give a talk about my experience migrating enterprise applications from an on-prem perspective into AWS. This is a project I undertook. It's been about 2 years now, but we did have some learnings and some challenges along the way, so I thought I'd share that. Okay, there you go. So my role, I'm a system software engineer, and I was put into this kind of platform migration effort, if we will, as a technical lead. And my primary responsibility was to interface between, I think, about 20 back office dev teams and AWS and Amazon AWS, along with the architecture and the security teams and other internal customers that uses these back office applications, right? Our goal was to ensure that we have security and development consistency, because there are about 20 teams. They all come from different varying experiences of AWS. They all are responsible for different types of back office applications. So the experience level, as well as the fear factor and the panic level, varies all the way across the different teams. And my role is to help recommend, empower them, as well as to help them troubleshoot and serve as sort of a liaison between these dev teams and our other teams within AWS and architecture. So jumping a little bit, oh, sorry, what happened? Can you go back one slide? Sorry, I'm not sure if I'm controlling the slide here. There we go. Sorry about that. So a little bit about enterprise back office applications. So these are the applications that support back office functionalities. And in my experience, these are usually the last to be migrated into the cloud, because they basically support the internal structure of the company. So you have systems or applications like privacy applications, or embargo country or sanctionless applications that controls whether we should do business with a embargo country. You have systems like EDI systems that control the order process with our retail partners. So these are not necessarily customer-facing applications. There's a mix of vendor and homegrown applications, and they're mostly designed for on-premise implementation. There's usually a high level of risk to the company for these applications. Even though they don't face the customers, there's a lot of legal and financial challenges to these. So for example, these control privacy settings for customers. And if something is not set correctly, the privacy auditors, we might run the risk of violating GDPR and other privacy settings, right? From a finance perspective, some of these are SOX systems. So they do control revenue, or they audit revenue. So any sort of downtime for these type of systems are taken very seriously. And it's because of that they're usually the last to be migrated to the cloud, because they're such entrenched in the company, and they've usually been on-prem for years and years. The tribal knowledge and the lack of documentation runs pretty high. So migrating these systems is usually a challenge, right? In fact, for us, these were the last set of systems to be migrated out of the on-prem data center. So some of the backgrounds and constraints that was forcing our hand to migrate these was that our company took a stance where there will be no data centers, right? We're not going with a hybrid model. So all the systems are going into the cloud. Basically, any systems that runs production workload are going to be in the cloud, in AWS in this case. So that decision was made after the CEO decided to sell our data center. Basically, we signed a contract, we sold all data centers, we ended all of our co-location contracts, right? Basically forcing our hands. Basically, we didn't want to be the last department to be stuck running a data center or running a portion of a data center, right? No more data centers, right? It's kind of like the story where the CEO pretty much burned all the ships, right? As we get to the new land. There's some additional constraints, right? We went with an immutable OS and application approach. So what that basically means is that we will burn a new image every time we do a release, right? Whether it's an OS release, whether it's application release, we pretty much generate a derived image in AWS and then deploy that image, right? So no changes to the server from an ad hoc perspective. Every time you want to do a release, you'll be a new image burn. There's some company cloud security guardrails that came in as part of this migration, right? Systems are rebuilt and redeployed every 30 days. That in itself caused a lot of angst, right? Basically, if you imagine we need to rebuild the system with a new image basically every 30 days. This is not something that you run into in the back office space, right? Usually back office systems are built once and then they run for years and years, right? Usually you can patch them and you can upgrade them, but they usually stay like that for years and years and years, right? We now also have a requirement that we encrypt basically everywhere. Encrypt in transit, encryption at rest, and no backhaul private path back to our corporate data centers. This is or corporate locations. This is basically the forcing everybody to go into the cloud for production. And there's some challenges in terms of this backhaul, no backhaul private paths. Basically, it means anytime you need to access a system, you will go through the internet. You go through the public interface. Each application in this case actually received their own account and own VPC. This is drastically different from back office applications that's on-prem. Usually back office applications that's on-prem are all located within a single subnet. They all talk to each other with no firewall ACL considerations because they are kind of internal. They're kind of behind the big shell, if you will, right? The big firewall. But with this transition, where every application has its own account VPC, it basically means that every application is now in its own little network, right? Complete with the VPC shell, with the firewalls and the security groups. Basically, it's a limit blast radius, but it is a kind of a mindset shift. And of course, I mentioned the multiple dev teams with varying level of cloud knowledge. Forward. Oop. So right here, this, okay. So we took 3 approaches, right? Our approach consists of, the general approach consists of 3 steps, right? The first step we did was we requested a deployment architecture from each of the teams. And this exercise was really to help the teams lay out their functionality within the cloud structure. I think up to this point, a lot of the dev teams are just aware of a systems level layout. Basically, where do you deploy code? I put the code into a system on on-prem. They don't necessarily have a lot of networking or even ACL type situation, right? Or awareness, because everything basically can talk to each other, right? So this, when you have a deployment architecture, it kind of lays out the code on top of some of the cloud resources, and it gives an overview of the high-level functionalities. It may call out dependencies and connections, and it kind of also provides a visual map that helps provide a sounding board against a security or other kind of gaps. So I kind of provided a diagram here, and we created a template of this diagram, but really this is an exercise to help the team kind of lay out and say, this is what a typical cloud deployment look like. Where would you put your code? And this gives the dev team a little bit of an idea of, okay, we need to split these things apart. We're going to have load balancers. We're going to have, security groups and VPCs, along with these egress and ingress dependencies, right? And so with this, we can take it to architecture. So remember, we have 20 teams. So if all teams abide by this sort of same diagram, it makes it easy for architecture and security and AWS to kind of take a look and say, okay, I see where this is. And also it helps kind of create patterns as you look across the different teams diagrams. Right. The second approach we took was to create a threat model for each one. Remember, these enterprise applications are usually kind of in the middle of a corporate structure on-prem. So the threat modeling could be a little bit loose, right? Because they deal with internal data and they talk to each other. So the threat model really is to help focus on the protocols and the inbound and outbound access to other services, right? It helps them create this mindset that you're no longer within the internal kind of firewall protected area. You are now outside in the cloud, right? There's external stuff that you need to be taken care of. And remember, we didn't have backhaul, right? It didn't have backhaul back to the corporate side. And so therefore, everything is now, this mindset needs to be that we're outside in the internet. Right. The threat model diagram is very similar to our deployment diagram, except now we call out protocols, and we have, we call the different ports and the traffic schemes, and then we have control bubbles that basically calls out the different areas of concern. Right. So let me dive down. This is at the top here. We call how you access the systems. With callouts for different controls, so that this exposes it out as in a data format, so that there could be more discussions around this. And the last approach we had, or the last thing that we had, was a security architecture and security checklist. Right. This calls out the different areas that we should be concerned with. I didn't, you can see this is an MVC checklist. So these kind of checklists can vary from company to company, but in general, it provides a template that helps each dev team go through, in addition to the diagrams, to answer some of these questions. And these questions could be different. They're probably most likely different between company to company, but they are put together to help the teams kind of get a universal and consistent feel and look throughout the journey. Okay, and so some of the learnings that we went through, right? So we found out that code changes are very likely in all the areas. This is because of security. This is because we might have to change the way we do things. So for example, previously, if you're calling APIs within each other, within the on-prem data center, now you're outside. And so your API needs to be protected, usually via API gateway. But that may involve code changes with additional modules and additional libraries, right? The internal application communications, that needs to be mapped out, right? The external communications maps out. The payload encryption, do we need to encrypt out payload? Do we need to encrypt out database? All this stuff kind of automatically bubbles up because of the security concerns. And one of the last learnings we had as well is we want to release all these. We want to take care of all these before we cut over into the cloud. Because once you're in the cloud, it kind of makes these changes a little bit more difficult. So you want to implement these changes or these modules and test them out from within an on-prem location before you go into the cloud. Other learnings that we've seen, right? Because of these security modules and implementations, what are the performance impact, right? Because previously, if you didn't encrypt traffic in between two services, now you start encrypting them, it's going to slow down. You now have to do performance testing and scalability testing, right? We had problems with vendor certifications because a lot of these applications were created for on-prem, right? So for example, we had one application where they kept their license keys in the database. So in an immutable model, you would always spin up a new version of a system before you shut down the older version, right? So that you have no downtime, so that the new version can take on the traffic load. Well, in this case, since the vendor kept the keys in the database and they reference these keys to see how many instances of application you can run, you can't have the new one come online because it will detect that the keys are being used by the older version, right? That's still running. So in this case, you probably have to talk to the vendor to say, well, this is how we're going to deploy, and we need to increase that number of keys, or we have to find some other way of making sure that we can bring up the new system without having it being constrained by the number of keys, right? We had challenges with operational access, GUI management, because we no longer have a backhaul, right? So we had to determine how we can access the GUI. We ended up using jump boxes for GUI management versus directly hitting the GUI themselves, right? There's no more proxies, and we need to figure out how to store our secrets. So coming back to a summary of kind of the project work, right? You got to understand your company's design constraints, right? And you have to delegate development time for security changes, right? These changes usually take the most time because they are foreign to the dev teams. Whether it's a pipeline or whether it's new modules or libraries that help encrypt systems, you got to allocate time to work with vendors, because just that one key issue that we ran to that vendor that took a couple of weeks, right? Because it has to go through vendor management. The vendor has to approve that, okay, we're now running, we're now going to a cloud type scenario versus the on-prem scenario. And for some of these vendors, this is a new thing for them. We have vendors that tell us that they've never had customers that's going to put their code or their application into the cloud. Now, would they agree? They might not agree to that, but the problem is we will not have an on-prem system to put this in. So our company, our CEO has said that we will not be taken hostage by a vendor, right? If the vendor says they cannot put us in there, we got to figure out a way to put it in there. However, the vendor needs to know that when their contract comes due, they're most likely not going to be renewed, right? So that's just something that we need to work through. The team's mindset shift is probably one of the largest things that we need to work through. No longer are we protected by traditional firewalls or segmentation. They just need to understand that we are in the cloud. So that part takes a little bit of you getting used to. And that's my presentation. Thank you. I'll open it up for questions.